Let's look at a one-tailed hypothesis test using T. And there's a typo here. You'll have to forgive me. The mean time of a 40-yard dash among high school athletes is 4.5 seconds. Fair enough. A sample of 25 high school athletes using Breathe Right strips showed a mean dash time of 4.452 seconds with a standard deviation of 0.120. So it's a fine distinction here. It's just a little bit of a reduction. We hypothesized that the Breathe Right strips decreased dash times. What are the null and alternate hypotheses for a one-tail test alpha of 05? So in this case, what I did, and this is going back to chapter 8, the last time we talked about this, the dash times among those Breathe Right users, I'm going to start off with the alternate and say it reduced it. It's going to make it below 4.5 for that hypothetical population mean of dash times among Breathe Right users. It lowered it below 4.5. Then I just have to ask myself, what's the opposite of that for the alternate, or for the null rather? The dash times among Breathe Right users is either greater than or equal to 4.5. In other words, it didn't have the intended effect of lowering it. Now, before I go there, on which side will the critical value of T this time go? Won't it be on the left? Absolutely. The reason I know that is because the arrow is over here. So that arrow's over here pointing to the left, and therefore the critical value is going to be on the left. Let's go check out what it is. By the way, here's another thing. N equals 25. What are my degrees of freedom going to be? Aren't they going to be 24? Absolutely. So I'll establish the critical boundaries on the T distribution. The degrees of freedom is n minus 1 equals 25 minus 1 is 24. And let's go check it out. Is it truly the case that the critical value is 1.711 negative? Remember, we determined it's going to be on the left side. So sure enough, I go to 24 degrees of freedom and one tail and 05. One tail, 05, 24 degrees of freedom. Let's go all the way down. 1.711 negative. Absolutely. So I got the right value for sure. Then let's do some math. A sample of 25 high school athletes using Breathe Right showed a mean dash time of 4.452, standard deviation of 0.120. Let's plug the numbers in. Here's my standard deviation. Here's my n. 0.120 over radical 25, 0.120 over 5, 0.024. And I left it to be four digits here to be exact. And then here's my t-test, and the numbers are a little bit clunky, but just walk with me. 4.452 minus 4.5 over that 0.024. Looky there, it comes out to exactly -2. How about them apples? Appreciate that. So I like getting that exact -2. It's easy to deal with. And where does that fit on my graph? Well, here it goes. Please accept or reject the null hypothesis one-tailed alpha of 05. We reject. The 2 falls outside that critical region. Here's the 1.711. And you remember from one-tailed test back in chapter 8, if it falls out here, that means we reject. There's no decision, really. It's just like weighing the piece of luggage at the airport. That's all there is to it. So here's my critical value. Here's my obtained. It falls outside. We reject the null hypothesis. That was nice. Now, it was by somewhat of a short margin, but nonetheless, we're rejecting it. There's something else I want to do. You might remember we talked about Cohen's D, the effect size, and I lamented the fact that his obituary appeared so late. Well, let's do that. And again, I always take absolute values with effect size. It's negative, but we just ignore that. So it'll just be 4.452 minus 4.5 divided by the standard deviation, imitating the formula right here. That's it. And that turned out to be 0.40. It was 0.48 over 0.048 over 0.120. It's 0.40. That was kind of a medium effect. It's certainly nothing to sneeze at, but it was just a medium effect that was driven up somewhat maybe by a largish sample of 25. But this is pretty much par for the course, and I think particularly on this problem where the degrees of freedom were actually in the table, it was easy to do. And not really a difficult problem at all from that standpoint. And I think I'll just pick up with the next one in the next clip.